Yeah, so we have the concept of negative frequency in this discussion. In signal processing or in wireless communications, often we encounter this term negative frequency. What does this mean? In general, all real functions, they have negative frequencies. Yeah. For instance, let me take cosine function. So I have cos omega naught t. So cos omega naught t is say e power j omega naught t plus e power negative j omega naught t over 2. All right. So if I take its continuous time Fourier transformation, you take its ct of t, so you get two spikes. Okay. An omega domain, this is x of j omega. Yeah, so I have two delta functions here. At omega is equal to positive omega naught, and at omega is equal to negative omega naught, you have two spikes of amplitude pi, or these two are delta functions. Okay, so this is a single tone component. Single tone means the spectrum has single frequency component. All right. Now, what we can understand from this is that let's think this way. So this is positive frequency component, and this positive frequency component corresponds to e to the power of positive j omega naught t, and this negative frequency component, this corresponds to e power negative j omega naught t. All right, and of course this negative frequency component, this is an image of this positive frequency component. We'll come to that later. All right, so the spectrum, of course, we know the spectrum of cosine, it looks like this. What happens for the time being, what happens if I do this? Let me discard this negative frequency component for now. Okay, you have only positive frequency component. And if e to the power of j omega naught t corresponds to this positive frequency component, then what happens? Then you're going to see this now. See, this fellow, e power j omega naught t, is nothing but cos omega naught t plus j sine omega naught t. All right. In the time domain, we have only cos omega naught t, but by considering only positive frequency component, we are trying to represent a complex quantity in the time domain, which we don't want. We didn't realize entire real signal, so we have complex stuff here. So it is very straightforward that combining this negative frequency component with this positive frequency component, then only we can represent a real signal. Otherwise, all real signals have negative frequency components. So this is the most fundamental point. Yeah, in the era of like signal processing or wireless communications, like whatever you deal with. And now let's try to support this even more graphically. Okay, so let me take this. X of t is my cosine function. So my cosine function cos omega naught t, we have half e power negative j omega naught t plus e power positive j omega naught t. Okay, let's try to plot these two quantities individually. Now the amplitude of this, if I take amplitude of e power positive j omega naught t, it is 1, and the phase component is positive omega naught t. Let's try to plot this one. Okay, so let me take a circle first. Let me have a unit circle because amplitude is 1. So let me have a unit circle first. Okay, let me take the circle. Okay, something. Now this is your circle. So my real axis, imaginary axis. Okay, So this is 1. So I have a unit circle 1, and this is some point on this circle. Okay, now this positive omega naught t, this is acting as phase component here. So with respect to y-axis, you can show this way, and this is what positive omega naught t. So assume that you were initially somewhere here. Now you want to move along the surface of this circle anti-clockwise direction. All right, let's try to plot this first. It's very simple. Yeah, let me take another color. Let me take this color. So this is, I want to plot imaginary component with respect to time. So imaginary with respect to time, because see, I have t variable here. I can vary this t so that the red point, this red point, it keep on move along the surface of this circle. Okay, now that can plot a sine waveform here on this scale, like I mean on this axis you can see here. Okay, so now initially you're here, the point is here, so this point indicates imaginary stuff is equal to 0. So imaginary stuff equal to 0 here. Now you keep move along this circle, and the moment you reach here, that means you are reaching maximum imaginary. So you can go like this, right? And again from here, this has become less imaginary, even less imaginary. Here imaginary quantity is again 0. So that is this. My sine wave is going weird. So that is this. Okay, imaginary component equal to 0. Again, you're becoming imaginary, more imaginary, even more negative imaginary. Okay, so you keep on travel like this. See, this is more negative imaginary. Again, you are becoming 0. That is this, and so on and so forth. Okay, it's simple. Now let me take this negative component, that is e power negative j omega naught t. So the amplitude of this is 1, and you have negative phase minus omega naught t. So just try to show that here. Okay, so this point from the origin, this is radius 1, and you have, this is negative omega naught t phase. Again, you keep on vary t so that you move now along clockwise direction. Okay, so how do we plot this? Again, you start your journey from here. Okay, now I want to plot imaginary component with respect to time. So again, you're starting from here. Here imaginary component is 0. Now you are moving towards this, and you touch here. This is negative imaginary. So I go like this, I touch negative imaginary here. And again, you keep move this way and touch this. Okay, in this case, imaginary component equal to 0. So see, imaginary component equal to 0 here. And again, you come and touch this. You're touching max imaginary. So this is max imaginary here, and so on like that. Yeah. So you have like violet waveform and red waveform. From this, it's very simple to understand. These two waveforms are exactly out of phase with respect to each other. That means they cancel out. So there is no imaginary stuff in this case. So simply what we can say is this. I can show it on one plot, but okay, let me take another one. Okay, this is T. So there is no imaginary stuff. Okay, by adding these two, by adding this and this waveform, finally there is no imaginary stuff, and that's it. And this is the beauty. That means if I add e power positive j omega naught t with e power negative j omega naught t, that corresponds to real signal in the time domain, real function in the time domain. You don't have any imaginary stuff. Okay, so I don't want something like this. That means I want something like this, only cost functions say. All right, so therefore what we can understand is that, so this e power j omega naught t, you can think this is like a phasor, a rotating say a rotating quantity to, along anti-clockwise direction, or direction of rotation is anti-clockwise by convention. And if I take e power negative j omega naught t, this is nothing but rotation or direction of rotation in the clockwise direction. Okay, so two opposite direction of rotations can be represented graphically something this way, right? And that's it. Now, if we try to plot the real stuff, because we can justify this formula also, how this formula is really working with cos omega naught t. And for that, of course, what we do is, again, let me take this unit circle. Now I want to plot a real component with respect to time. So for that, what we do is this. This is real axis. This is imaginary axis. Okay. This is your, say, origin. We are done with this imaginary component. Now let's go for real component. Okay. All right. So anyways, let me take this. For positive omega naught t, you have anyways unit radius. Let me take some point here. This is positive omega naught t. Now what we do is, let's try to plot real quantity with respect to time. Okay, say initially you are here. Initially you are here. Now what is this real stuff? This real stuff is 1. That means I want to start from here, okay, from this point. As it is 1, so real component is 1. Now you want to move for e power positive j omega naught t, you want to move anti-clockwise direction. Okay, so because you're increasing the, you are changing the value of t by varying t, the point moves along the surface of the circle, say. Now when you move away from this point, okay, you are moving into complex zone. That means it's becoming like less real. So it's becoming less real. It's coming down. By the time you reach here real component is completely 0. Okay, so therefore yeah, so real component is 0 here. And again you move like this, and you can of course plot. Okay, you can of course plot. By the time you reach here, this is like -1. Real component is -1. So this is, say, -1. Right. So finally, what I have is this. Again, you come here, real component is 0. So real component is 0 here, and so on and so forth. That's it. So again, you get a waveform, a real waveform, something this way. Now we will take another one, that is, you have e power negative j omega naught t, yeah, with amplitude 1, and of course with phase negative omega naught t. And now you start your journey from this point again. And of course, for negative j omega naught t, you move clockwise direction. Okay, so I start my journey here as usual. So this journey, this real journey from this point is 1 again. So again, I start from 1. Now, how are you moving here? You're moving this way. Okay, and you touch this one now. So here, touching this means real quantity equal to 0. That means you are just moving like this along this black waveform, the red waveform is following, and this is 0, this one. Okay, again you move clockwise and you touch this, so this is -1. Okay, so you go this way and you're touching this, so this is again of course -1, and again from here to this. Okay, so from here to this, here imaginary component is there, real component is 0, so real component is 0 here, and again you're coming like this, so whatever. So that's it. So this is what you have. So from this, the black wave and red wave got superimposed. And what we can say from this is that simply they are in phase, exactly they are in phase. So we can quickly add these two quantities. Okay, let me add these two. So if I add these two, we get like this. Yeah. So the amplitude this time is 2. I have 2 here, not 1. So therefore, if I multiply this stuff, okay, let me multiply this first. So, but I want cos omega naught t. I want 1 cos omega naught t, not twice cos omega naught t. So if I multiply this by half, this by half, then what happens? Half into this, twice the waveform. If I do, then I get this cos omega naught t. And that's the reason here you have the scaling component as half. Okay, so half of this is what your cos omega naught t, because yeah, see, this is what you're multiplying here. So half of this 2 becomes of course this waveform again. This is 1 cos omega naught t. So as a whole, what we can understand is that whenever we encounter negative frequencies in the spectrum, you will have to understand that it is representing a real signal in the time domain. Yeah, I hope you understood this. Okay, further concepts we will check with our upcoming videos. Thank you.